सपोज एक बॉडी है जो एक्स एक्सिस के 2 पॉइंट पर रखी हुई है, वो बॉडी वहां से ट्रेवल करते हुए 6 और 4 पर पहुंच जाती है। जो हमारे पास वेलोसिटी आएगी वो आएगी 6 - 4, 4 - 0 डिवाइडेड बाय 5, जो कि हमारे पास 5 सेकंड्स में वो पहुंची है वहां से वहां तक। तो इसमें हमें वेलोसिटी निकालने के लिए सिंपल फॉर्मूला लगाना है। जो हमारी वाई एक्सिस है वो डिस्टेंस है, जो हमारी एक्स एक्सिस है वो टाइम है। तो वेलोसिटी निकालने के लिए हम सिंपल क्या करेंगे, s2 - s1 divided by t2 - t1, which means s2 is the final position of the body and s1 is the initial position of the body, t2 is the final time and t1 is the initial time. So this is how we will take out the velocity out of distance time graph. सेकेंड टाइप का जो ग्राफ होता है वो होता है हमारे पास वेलोसिटी टाइम ग्राफ। इसमें हम एक्सेलरेशन निकालने की कोशिश करते हैं। सबसे पहले हमारे पास एक फाइनल पॉइंट है और एक इनिशियल पॉइंट है, तो उसमें जो वाई एक्सिस है वो हमारी वेलोसिटी है। तो वेलोसिटी को जब हम फाइनल वेलोसिटी को जब हम इनिशियल वेलोसिटी को सब्ट्रैक्ट करेंगे और उसको डिवाइड करेंगे फाइनल टाइम फ्रॉम द इनिशियल टाइम, तो हमारे पास एक्सेलरेशन आ जाएगा। तो डिस्टेंस टाइम ग्राफ से हम वेलोसिटी निकालते हैं और वेलोसिटी टाइम ग्राफ से हम एक्सेलरेशन निकालते हैं। अभी हम पढ़ेंगे equation for the velocity time relation. You can see that initial velocity of the object is u at the point A. It increases to v at point B in time t. The velocity changes at a uniform rate A. Perpendicular lines BC and BE are drawn from the point B on the time and the velocity axis respectively, so that the initial velocity is represented by OA. The final velocity is represented by the BC and the time interval t is represented by OC. The change in velocity in time interval is represented by dt is equal to bc minus cd. So now let us draw a AD parallel to OC. From the graph we observe that BC is equals to BD plus DC is equals to BD plus OA. Now substituting BC is equals to V, which is final velocity, and OA is equals to U, which is initial velocity, and we get V is equals to BD plus U. So now we can find BD is equals to V minus U. The acceleration of the object is change in velocity divided by time taken, which is BD upon AD is equals to BD upon OC. Now substitute OC with time, which is t. From here we can say that acceleration A is equals to BD divided by t, or BD is equals to AT. So from above equation we can equate BD values. So we found that V minus U is equals to AT, and the first equation is V is equals to U plus AT. Now equation 4, position time relation. Let us consider that the object has traveled a distance s in the time t under uniform acceleration a. The distance traveled by the object is obtained by the area enclosed within OABC under the velocity graph AB. Thus, the distance s traveled by the object is area OABC, which is a trapezium, which is equals to area of rectangle OADC plus area of triangle ABD. So we can say that OA multiplied by OC plus 1 upon 2 AD multiplied by BD. Now we will substitute the value OA with U, which is initial velocity, OC is equals to AD is equals to time, and BD is equals to AT, which we get from the first equation. So distance, which is S, is equals to U multiplied by T plus 1 upon 2 T multiplied by AT. So here we can say that distance S is equals to UT plus 1 upon 2 AT square, which is the second equation of motion. Now we will try to find out the third equation of motion. The equation for position velocity relation. From the velocity time graph, the distance s traveled by the object in time t moving under uniform acceleration a is given by the area enclosed with the trapezium OABC under the graph. So s is equals to area of trapezium OABC. So the formula of area of trapezium is OA plus BC into OC divided by 2. Substituting OA is equals to U, which is initial velocity, BC with V, which is final velocity, and OC with T, which is time. So from here, we can say that distance S is equals to V plus U multiplied by T divided by 2. So from the velocity time relation, we know that T is equals to V minus U upon A. We put this into this equation. So distance S is equals to V plus U multiplied by V minus U upon 2A. So by the mathematical equation a square minus b square is equals to a plus b, a minus b, we can say that v plus u multiplied by v minus u is equals to v square minus u square. So the new equation is 2 multiplied by a multiplied by distance s is equals to v square minus u square.